Welcome to our factory. Today, I'll show you exactly how solar panels are made, step by step.
Today, we're taking you inside a modern state-of-the-art solar panel facility to see exactly how these powerful machines of light are made, step by step, from raw silicon all the way to the rooftops of homes around the globe. Raw materials and preparation silicon arrival. Every solar panel begins with one essential element, silicon, extracted from quartz rock and purified across several stages. Silicon is the backbone of nearly all solar technologies. As shipments of raw silicon arrive at the factory, workers carefully unload the material and verify its purity. These crystals may look simple, but the energy potential hidden within them is massive. Initial measurement and handling the silicon is crushed, sorted, and measured into carefully controlled quantities. Precision is everything. Even the smallest variation can affect the solar cell's efficiency. Technicians monitor the process closely as the material is transferred into high-grade stainless steel containers. Ready for melting. Transport to furnaces from here, automated systems take over. Using conveyor belts and robotic carriers, the factory moves the raw silicon to enormous furnace rooms. It's here that the transformation truly begins. The temperature rises, the air vibrates with a low industrial hum. The science of turning stone into a conductor of sunlight is now underway. Mixing and processing ingot creation and wafer and purification inside massive crucibles. Silicon heats to more than 1,400 degrees Celsius, hot enough to melt solid crystal into glowing liquid. During this stage, impurities are removed to achieve near-perfect purity. Clean silicon means higher efficiency, so every second of this process is monitored with advanced sensors and real-time data systems. Control room operations in the control center. Technicians oversee temperature curves, purity graphs, and crystal growth patterns. Every number on these screens represents a vital part of the process. These experts ensure the molten silicon cools at the exact rate needed to form a perfect monocrystalline ingot, a giant cylinder of pure solar-ready silicon. Ingot handling. Once cooled, the ingots are transported to the slicing department. Robotic arms lift the large cylinders with delicate precision. The factory becomes a dance of motion, machines gliding tracks, conveyors moving effortlessly. The ingots are now ready to be cut into something extraordinary, the thin wafers that will one day capture the sun. Transformation, core production, wafer slicing, cell texturing, and printing. Wafer slicing. Diamond wire saws glide through the ingots, slicing them into extraordinarily thin wafers, often less than 200 micrometers thick. The cutting process must be flawless. A single micron of error can lead to a defective cell. The sliced wafers fall away like shimmering pieces of glass, each one a future building block for solar-powered cell printing. Next, the wafers are moved to the cell printing area. Here, anti-reflective coatings are applied to maximize light absorption. Using precise screen printing systems, the factory prints an intricate network of silver lines, the electrical pathways that will carry sunlight-generated electrons through the panel. Robotic arms handle the wafers gently, placing them onto printing stations. The environment here is controlled, sterile, and bright. Every cell undergoes measurement, inspection, and alignment to guarantee maximum efficiency. Transformation under UV curing. Once printed, the wafers move beneath powerful UV curing lights. As the coatings set, the cells display iridescent colors, blues, purples, and greens. This beautiful transformation marks the birth of a functioning solar cell, from stone to crystal to wafer. Now the cell is ready to generate electricity from sunlight. Assembly and panel construction. Cell layout and interconnection in the assembly department. Solar cells are arranged in precise rows on a sheet of tempered glass. Robotic systems solder thin metal ribbons between cells, connecting them into a unified electrical network. Each connection must be flawless. Even one weak joint can reduce overall performance. Lamination. Once assembled, the cell matrix is layered with EVA encapsulant films and a durable backsheet. These materials protect the cells from moisture, dust, and extreme temperatures. The stack enters a massive vacuum laminator, where heat and pressure fuse everything into a single solid panel. Framing and finishing. After lamination, the panel receives its aluminum frame and junction box. Robots tighten each screw with exact torque, ensuring structural integrity. Workers inspect the edges, clean the surface, and prepare the panel for the critical stage that comes next: testing, quality check, and distribution. Flash testing. Every panel enters a flash testing chamber, a controlled environment that simulates sunlight in a single powerful burst. Sensors measure voltage, current, and efficiency. If a panel performs even slightly below expectations, it is flagged for further inspection. Quality is not negotiable. Solar panels are expected to last 25 to 30 years. This testing ensures each one can withstand decades of real-world conditions. Final inspection and packing. After passing electrical and visual inspections, the panels move to the packing area. Workers secure them in protective crates, attach tracking labels, and prepare them for transport. Loading and distribution. Forklifts carry stacks of finished panels to delivery trucks waiting at the loading docks. These panels may soon be installed on rooftops, in solar farms, or powering entire community grids. From here, their journey continues across cities and continents, each one ready to turn sunlight into clean, renewable energy. And that is how solar panels are made, from raw silicon to fully assembled high-performance energy generators. It's a process built on precision, innovation, and the shared mission of creating a more sustainable world. If you enjoyed this inside look at modern manufacturing, be sure to subscribe for more factory tours, process documentaries, and cinematic industrial videos. Thanks for watching, and remember, the future is powered by the sun.